Hi, in this video we are going to discuss hybridization. This is just extension of Valence Bond Theory. According to Valence Bond Theory, these are the half-filled atomic orbitals which overlap and form the covalent bond. But Valence Bond Theory cannot explain many compounds, like beryllium chloride. Here beryllium form two covalent bonds but have no half-filled orbitals. And in CH4, carbon form 4 covalent bond but have two half-filled orbitals. In like these compounds, the bonding of central atom cannot be explained without the hybridization concept. This is because here the central atom do not have enough half-filled orbital as the number of covalent bonds. Hybridization. The concept of hybridization was given by Linus Pauling in 1931. According to hybridization concept, these are the atomic orbitals which have different energy but close to each other and have different shapes. These atomic orbital mix and form equal number of atomic orbitals which have same energy and same shapes. Then these orbitals overlap and form covalent bonds. There are different types of hybridization. The first one is sp hybridization, in which one s and one p orbitals of the central atom are being hybridized. In Ap2 types molecules, for example beryllium chloride, carbon dioxide, hydrogen cyanide, etc. In these types molecules, the central atoms are being hybridized by sp hybridization. When we see the electronic configuration of beryllium, there is no half-filled orbitals. But from 2s orbital, one electron is being excited to 2px orbital. Then 2s and 2px orbitals mix and form two hybridized sp orbitals, which have same energy and same shape. Now these orbitals are half-filled and can overlap with two orbitals and form two covalent bonds. This is the shape of sp hybridized orbital. Here beryllium has two sp hybridized orbitals which overlap with the p orbital of chlorine. Sp hybrid orbital or p orbitals which are half-filled orbitals. These overlap and form sigma bond or beryllium chloride molecule. Here the bond angle is 180 degree and the geometry of this molecule is linear. S and p orbitals have different shape or energy, but after hybridization, sp hybridized orbitals have same energy or same shape. And when we see the electronic configuration of carbon, these have two half-filled orbitals which are 2px and 2py. But this formed four covalent bonds. One electron from 2s orbital is being excited to pz orbital. And then 2s and 2p orbitals mix and form 2sp hybridized orbitals. There are two unhybridized orbitals which are also half-filled. So we can say after hybridization one carbon has four half-filled atomic orbitals, in which two atomic orbitals are unhybridized and two atomic orbitals are sp hybridized. These two types of orbitals are right angled to each other. Here from two carbon atoms, two sp hybridized orbitals overlap head to head and form sigma bond. and 4 unhybridized p orbitals, 2 from each carbon overlap side by side and form 2 pi bonds. Now, 2 left sp hybridized orbitals overlap with the s orbitals of hydrogen atoms and form sigma bond. In this way, after hybridization carbon form acetylene molecule, which have 2 pi bond and 3 sigma bonds. Here the bond angle is also 180 degree and the geometry of this molecule is also linear. sp² hybridization. Here 1s and 2p orbitals mix and form 3 sp² hybridized orbitals. In Ab3 types molecules like aluminum chloride Bf3 and Ab2E types molecule like stannic chloride, here in such types of molecule the central atoms are being sp² hybridization. Boron has one half-filled atomic orbital, but this forms 3 covalent bonds. One electron from 2s orbitals is being excited to 2p orbital. Then s orbital and 2p orbitals mix and form 3 sp² hybridized atomic orbitals, which have same energy and same shape. This is boron, which has 3 sp² hybridized atomic orbitals. These half-filled hybridized atomic orbitals overlap with the p orbitals of fluorine, which are also half-filled and form 3 sigma bonds. And when we see the geometry of Bf3 molecules, this is trigonal, which have the bond angle 120 degree. In case of Sn, one s orbital and 2p orbitals mix and form 3 sp² hybridized orbitals. Here one sp² hybridized orbital is completely filled and 2 sp² hybridized orbital are half filled. This is hybridized Sn atom which have one filled sp² hybridized orbital and 2 half filled sp² hybridized orbitals. Half filled sp² hybridized orbitals overlap with the p orbital of chlorine and form sigma bonds. This is V-shaped molecule. Here one lone pair electron cause repulsion and bond angle become less than 120 degree. Carbon also goes sp² hybridization. One electron from 2s orbitals is excited to 2p orbitals. And then 2s, 2px and 2py orbitals mix and form 3 sp² hybridized atomic orbitals. There is one unhybridized 2p half-filled atomic orbital. This is carbon, which is sp² hybridized, which have 3 sp² hybridized atomic orbital and 1p unhybridized orbital. This is second carbon, which is also sp² hybridized. Here, 2 sp² hybridized atomic orbital overlap and form one sigma bond, and other hybridized sp² hybridized atomic orbitals overlap with the s orbital of hydrogens and form sigma bonds. While on the other hand, unhybridized atomic orbital overlap side by side and form pi bond. So in this way this molecule has 1 pi bond and 5 sigma bonds. And we can say these are hybrid orbitals which form sigma and lone pair electrons. And these are anhybridized atomic orbitals which form pi bonds. sp³ hybridization, in which 1s and 3p atomic orbitals mix and form 4 sp³ hybridized orbitals. The central atom in Ab4 types molecule, Ab3E types and Ab2E types molecule have sp³ hybridization. For example, CH4, CCl4, NH3, PH3, water molecule, and hydrogen sulfide. In all these molecules, the central atom is sp³ hybridized. Carbon also undergoes to sp³ hybridization. Similarly, here one electron from 2s orbital is being excited to 2p orbital. And then 1s and 3 2p orbitals mix and form 4 sp³ hybridized atomic orbitals, which have same energy and same shape. This is carbon atom, which is sp³ hybridized, so have 4 sp³ hybrid atomic orbitals, which overlap with the s orbitals of hydrogen and form 4 sigma bond. In this way, carbon forms CH4 molecule, which have bond angle 109.5 degree, and the geometry of this molecule is tetrahedral. In case of nitrogen, 1s and 3p orbitals mix and form 4 sp³ hybridized atomic orbitals. In these 4 hybridized atomic orbitals, one is filled and other 3 are half-filled atomic orbitals. So we can write this is nitrogen, which is sp³ hybridized, which has 3 sp³ hybridized which are half-filled and 1 sp³ hybridized orbital which is filled. Here 3 sp³ hybridized atomic orbitals which are half-filled overlap with the s orbitals of hydrogen and form 3 sigma bond or NH3 molecule. And the geometry of this molecule is trigonal pyramid, as this form trigonal or pyramid shapes. As this molecule has one lone pair electron which causes repulsion, so the bond angle decreases from 109.5 to 107 degree. And in case of oxygen, 1s and 3p orbitals mix and form 4 sp³ hybridized orbitals, in which 2 are filled and 2 are half-filled. So we can write this is oxygen, which is sp³ hybridized, which has 2 sp³ hybridized which are filled and 2 sp³ hybridized which are half-filled, which overlap with the s orbitals of hydrogen and form 2 sigma bonds. Geometry of this molecule is V-shaped, and here there are 2 lone pair electrons which cause repulsion, so the bond angle is less, which is 104 degree. And in case of hydrogen sulfide, sulfur has sp³ hybridization like oxygen atom. But here the bond angle is 92 degree, which is due to higher size of sulfur, which has higher electronic density and causes greater repulsion. dsp³ hybridization, in which 1s3p and 1d which is d² orbitals mix and form 5 dsp³ hybridized orbitals. The central atom have dsp³ hybridization in Ab5 type molecules like PCl5, Ab4E types molecule like SF4 molecule, Ab3E2 types molecules like ClF3 molecule, and Ab2E3 types molecule like XeF2 molecule. In all these molecules, the central atom have dsp³ hybridization. When we see the electronic configuration of phosphorus, this has 3 half-filled atomic orbitals. But phosphorus in PCl5 molecule form 5 covalent bonds. Here all d orbitals are empty, but one electron from 3s orbitals excited to 3dz² orbitals, and then 3s3p and 1 3d orbitals mix and form 5 dsp³ hybridized atomic orbitals. So we can write this as phosphorus, which is dsp³ hybridized and have 5 dsp³ hybridized atomic orbitals which are half-filled, which overlap with the p orbitals of chlorine and form sigma bonds. In this way, by overlapping of dsp³ orbitals and p orbitals of chlorine, phosphorus form PCl5 molecule. PCl5 molecule has 3 types of bond angle, which are 90 degree, 180 degree and 120 degree. This is because PCl5 molecule has 2 types of bond, which are axial and equatorial, which we have discussed in vascular theory. And the geometry of this molecule is trigonal bipyramid, as this molecule form trigonal and 2 pyramid shapes. As you can see, in SF4 molecule, the sulfur is also dsp³ hybridized, which has 1 filled dsp³ hybridized orbital and 4 half-filled dsp³ hybridized orbitals. Here, 4 hybridized half-filled atomic orbitals overlap with the p orbitals of fluorine and form sigma bond. And 1 filled atomic orbitals or lone pair electrons which cause repulsion. So the bond angle decreases and the geometry of molecule become like seesaw. In ClF3 molecule, chlorine is also dsp³ hybridized, which has 3 half-filled hybridized atomic orbitals and 2 filled hybridized atomic orbitals. Here, half-filled atomic orbitals similarly overlap with the p orbitals of fluorine and form sigma bond. And 2 filled atomic orbitals or lone pair cause repulsion, which decrease the bond angle, and the geometry of these molecules becomes like T-shape. And in XeF2 molecule, xenon is also dsp³ hybridized, which has 2 half-filled and 3 filled hybridized atomic orbitals. Here, 2 half-filled orbitals similarly overlap with the p orbital of fluorine and form sigma bond. And 3 filled or lone pair electron cause repulsion in such a way, geometry of this molecule become linear. sp3d2 and d²sp³ hybridization, in which one has 3p and 2d orbitals which are dz², the x², y² mix and form 6 hybridized atomic orbitals. The difference between these two hybridization we will discuss in VBT complex formation in the next video. In AB6 type molecules like SF6 molecule, AB5 E types molecules like IF5 molecule, AB4 E2 types molecules like XeF4 molecule. Here in all these molecules, the central atoms are sp3d2 hybridized. Sulfur atom has two half-filled atomic orbitals. Here all d orbitals are empty. But here one electron from 3s and one electron from 3p are being excited to 3dz² and 3dx²y² orbitals. After that, one s3p and two d orbitals mix and form 6 sp3d2 hybridized atomic orbitals, which have equal energy and same shape. This is sulfur atom, which is sp3d2 hybridized, so has 6 sp3d2 hybridized atomic orbitals which are half-filled. These half-filled hybridized atomic orbitals overlap with the p orbitals of fluorine and form 6 sigma bonds. In this way, sulfur forms SF6 molecule or 6 sigma bonds between sp3d2 hybridized orbitals and p orbitals of fluorine. And the geometry of this molecule is octahedral, as this molecule forms 4 heads on one side and 4 heads on another side. So the geometry of this molecule is octahedral, as you can see. And this molecule forms two types of bond angles, in which one is 90° and other is 180°. In IF5 molecule, iodine is also sp3d2 hybridized, which has 1 filled and 5 half-filled atomic orbitals. The half-filled atomic hybridized orbitals overlap with the p orbital of fluorine and form 5 sigma bonds. And one filled or lone pair electron causes repulsion, so the bond angle decreases, and the geometry of this molecule is square pyramid, as this forms square or pyramid shapes. And in XeF4 molecule, here the central atom is also sp3d2 hybridized, which has 4 half-filled and 2 filled hybridized atomic orbitals. Half-filled hybridized atomic orbitals similarly overlap with the p orbitals of fluorine and form 4 sigma bonds. And filled or lone pair electron cause repulsion in such a way the geometry of this molecule becomes square planar. Here sigma bonds form between sp3d2 hybridized atomic orbital and p orbital of fluorine atoms. sp3d3 hybridization, in which one has 3p and 3d orbitals, which are dxy, dyz and dxy orbitals are involved. The central atoms in AB7 types molecules are sp3d3 hybridized. For example, IF7 molecule. Here iodine is sp3d3 hybridized. iodine has one half-filled atomic orbital and empty d orbitals. But here electron from 5s, 5px and 5py are being excited to dxy, dyz and dxy orbitals. After that, 1s3p and 3d orbitals mix and form 7 hybridized atomic orbitals, which have same energy and same shapes. So this is the iodine, which is sp3d3 hybridized, having 7 half-filled atomic orbitals which are hybridized. These overlap with the p orbitals of fluorine and form 7 sigma bond or IF7 molecule. And the geometry of this molecule is pentagonal bipyramid, as we have discussed in detail in Valence Bond theory in previous video. Thanks for watching, and please comment if you have any question.